In this lesson, we will decide whether the krypton-fluorine bond is polar or nonpolar. We will use the idea of electronegativity and the difference in electronegativity called delta En. A bond is polar when the two atoms pull on the bonding electrons unequally. That happens when the difference in electronegativity, delta En, is not small. As a simple rule of thumb, if delta En is around 0.4 or less, the bond is usually nonpolar. If it is larger than that, the bond is usually polar. Now let us compare krypton and fluorine directly. On the left, krypton. On the right, fluorine. Fluorine is the most electronegative element, about 3.98 on the Pauling scale. Krypton, a noble gas, is much lower or sometimes listed as undefined, but commonly taken as about 3.0 in data tables. So fluorine pulls electron density toward itself in a Kr-F bond. Let us calculate delta En explicitly. Delta En equals the absolute value of En of fluorine minus En of krypton. That is absolute value of 3.98 minus 3.0, which is 0.98. Now compare 0.98 to our threshold of about 0.4 to 0.5. 0.98 is larger, so the Kr-F bond is polar. So the correct choice is A, polar. We will highlight option A now. One extra note, krypton difluoride is a real compound with two Kr-F bonds in a linear shape. Each Kr-F bond is polar, but the molecule overall is nonpolar because the two bond dipoles cancel. Final intuition, fluorine has the stronger pull, so electron density shifts toward fluorine, leaving krypton slightly delta plus and fluorine slightly delta minus. That is the signature of a polar bond. Summary, the Kr-F bond is polar because delta En equals 0.98, which is larger than the nonpolar threshold.